Welcome to this explainer. Today, we are stepping into the role of your symphony conductor. We're going to orchestrate an absolutely perfect exam strategy for Cambridge Physics 0625, and we're going to do it by mastering one of the most crucial, high-stakes topics on the entire syllabus: half-life. Think about it. A top-tier exam answer is exactly like a beautifully conducted symphony. Every single calculation, every piece of terminology, and every explanatory sentence has to work in perfect harmony. But when faced with complex half-life questions from past papers, we typically see two distinct types of students struggling to make that music. First, you've got Alex. Now, Alex studies hard, but Alex overloads their answers with raw, unfiltered physics facts. There's zero analysis, it's just a brain dump, creating chaotic noise on the page rather than a clear, logical argument. And then there's Sam. Sam completely rushes through the paper, panics at the sight of complex data, and completely misses the specific command word requirements. Well, today we're taking those flawed, red pen-covered approaches and transforming them into flawless, green checkmark responses. Let's dive right in.
So, did you know that the core concepts and applications of half-life account for approximately 15% of the total marks in your Cambridge 0625 exam? Now, let that sink in for a second. 15%. That is literally the exact difference between an average middle-of-the-road grade and a top-tier A-star result. Aiming for those top marks means you absolutely have to move beyond a superficial rote memorization understanding of radioactive decay. The principal examiner reports consistently highlight this. They tell us, year after year, that students who demonstrate a deep conceptual mastery of half-life, students who can systematically analyze data and use evidence-based reasoning, achieve significantly higher marks across the whole paper. It's not just about knowing the facts, it's about how you use them. This 15% represents a massive opportunity to boost your grade, once you decode what the examiners are actually looking for.
To get you those marks, we are opening up the examiner's playbook. We're going to systematically break down exactly how you can maximize your grade using the structured 5-part agenda. 1. The half-life core principle. 2. Real-world applications. 3. The technical methodology. 4. Critical analysis. And 5. Top examiner warnings.
All right, Section 1. The half-life core principle. Let's build that foundation. Okay, listen carefully, because this is the absolute core principle you must memorize verbatim. The definition of half-life is precisely this: the time taken for half the nuclei in any sample to decay. Now, you might be thinking, yeah, I know that, but every single word here matters immensely. When asked to define half-life, a student like Alex, remember our fact overloader, might write a massive, vague paragraph about radioactivity, alpha particles, and energy, just hoping something sticks to the wall. But the examiner, they are literally scanning your page with a specific checklist. They need to see the phrases half the nuclei, any sample, and time taken. If you miss even one of those details, the harmony of your answer is completely lost, and you drop an easy mark. You have to anchor your responses in this fundamental physics definition first, before you start building your evidence and your explanation. Moving right along to Section 2, Real-World Applications. The syllabus explicitly emphasizes that top-performing students must exhibit a conceptual understanding that transfers directly to everyday contexts. We're talking about household smoke alarms, food irradiation, sterilization of medical equipment, measuring the thickness of paper or aluminum, and cancer diagnosis and treatment. Now, let's look at how our rusher, Sam, handles a question about smoke alarms. If the command word is explain how a smoke alarm utilizes radioactive decay, Sam might just scribble, it uses alpha particles because they don't travel far, and move on. That approach hemorrhages easy marks. Instead, your logical argument must be orchestrated using what we call the Peel framework: point, evidence, explanation, link. First, make your point. Smoke alarms use an alpha emitter, like americium 241. Then provide the evidence. Alpha particles highly ionize the air inside the chamber. Next comes the explanation. Smoke blocks these alpha particles, which drops the electrical current and triggers the alarm. And finally, link it back to the core concept. The isotope must have a very long half-life, over 400 years, so the homeowner doesn't have to constantly replace the alarm. See the difference? That is how top students structure their physics answers. So the crucial question we have to ask ourselves right now is, why? Why, despite knowing these applications and definitions, do students struggle so incredibly hard with complex exam data on this topic? Well, the answer lies in the gap between just memorizing facts and actually applying them. Cambridge's academic benchmarks require logical, structured reasoning. If you treat physics like a vocabulary test instead of a logic puzzle, you're going to completely panic the second you face an unfamiliar graph or a weird data table. Decoding the core requirements of those command words is your missing link.
Before we continue, subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click that subscribe button and hit the bell icon right now.
Let's jump into Section 3, the technical methodology. Now we're going to discover exactly how to deconstruct those complex questions using what I call the method mark strategy. This is your physics success blueprint. It's a standardized 5-step sequence that guarantees you capture those process marks that examiners are desperately looking for. Step 1, identify key elements to extract the relevant data from the noise. Step 2, apply relevant principles, meaning select your analytical framework, like the Peel method we just talked about. Step 3, execute your analysis with crystal clear working. Step 4, verify your results. Does the answer actually make logical sense? And step 5, present it in the appropriate format with correct units. Imagine a question asking for the remaining mass of a 100-gram radioactive sample after 3 half-lives. A flawed, rushed answer just writes 12.5 grams at the bottom. If they make one tiny calculator error, they get 0 marks. A perfect answer shows the exact sequence. 100 divided by 2 is 50. 50 divided by 2 is 25. 25 divided by 2 is 12.5 grams. Showing your exact methodology is what transforms potential red penalty marks into gorgeous green check marks.
All right, it is time for an interactive workshop. Let's put your methodology to the test with Challenge 1, the data scan. Pretend there's a 60-second visual countdown timer right in front of you. When you face complex data like this table in an exam, your visual data interpretation skills are absolutely critical. You have to extract the core trend to draw evidence-based conclusions. Ready? Go. At 0 days, we start with 1,000 undecayed nuclei. At 5 days, we have 500. At 10 days, we're down to 250. Okay, let's apply our core principle. Half-life is the time taken for half the nuclei to decay. Going from 1,000 down to 500 takes exactly 5 days. Going from 500 down to 250 takes another 5 days. Boom, time's up. Therefore, the core trend you extract is a constant half-life of 5 days. This is exactly how you interpret relationships systematically under pressure, rather than just panicking and guessing.
Stop scrolling! Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCE to excel in your Cambridge examinations. We've helped thousands of students improve by 2 to 3 grade boundaries. Join them right now by subscribing to @acetheexams_IGCE and turn on all notifications so you never miss our weekly exam strategy sessions.
Welcome back. Let's move straight into Section 4, critical analysis. Now for Challenge 2, find the flaw. I want you to evaluate this comparative evidence. Look at how incredibly vague this flawed sample paragraph is. Both applications use radiation, but one is for food. Do you see the sentence losing marks? It's the whole thing. It loses marks because it fails to identify the type of radiation, and it completely ignores the physics mechanics. Now let's look at Challenge 3, speed writing. If you had 30 seconds to write a perfect Peel paragraph, it should look like this. While both utilize gamma decay, food irradiation requires a longer half-life than. This is magnificent. Why? Because it uses comparative connectives, like the word while, and it supports the comparison with highly specific evidence, explicitly naming gamma decay. Whenever you are comparing applications, you must establish the physical properties, cite their specific penetration power, and always link it back to the half-life of the chosen isotope. Finally, Section 5, top examiner warnings. Let's bring this all together into our final system. To achieve your full mark potential, you absolutely must avoid these top 3 pitfalls, pulled directly from the principal examiner reports. First, answers that are way too vague. Writing radiation is dangerous instead of specifying alpha particles are highly ionizing but have low penetration will cost you dearly. Second, forgetting to check the final format and presentation. When you're calculating and drawing decay curves, your axes must be clearly labeled and your curves must be smoothly drawn. Presentation is a massive, sneaky area for lost marks. And third, failing to tie your answer to the specific context given. If the exam question is specifically about a nuclear power reactor, your response shouldn't be waffling on about a household smoke alarm. Let the context act as your conductor and simply follow its lead. You have to use a time management matrix here. Decode the command word, apply the Peel framework, and allocate your time based purely on the marks available. This direct quote brilliantly illustrates our ultimate insider rule. You must establish your analytical depth by defining your terminology first. The examiner explicitly states, candidates consistently confuse key terminology. They confuse isotopes with ions, or they confuse decay rate with half-life. Don't fall into that trap. Whether you are sitting for syllabus 0625, 0651, 0652, 5054, or even looking ahead to A-level physics 9702, a robust answering system is built on these unshakable rules.
Decode those command words to show your reasoning, structure your points with clear evidence, and manage your time matrix so you never, ever rush a complex analysis question like our friend Sam.
Listen, students who implement these physics strategies see an average improvement of 2 grade boundaries, but only if they practice consistently with our weekly videos. Here's your final reminder. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Subscribe right now to @acetheexams_IGCSE and click that bell. Don't let another exam pass you by.
Drop a comment below with your target grade for physics and the biggest challenge you're facing. Is it the decay curve calculations, or is it structuring those Peel paragraphs? Let us know, because our team responds to every comment. Like and share this video with a study partner. Ace the Exams, your Cambridge success starts here. Remember, your exam answer is your symphony. Make sure every single note counts. See you next time.